Hi, and welcome back to Geology. This is Miss Sparks, and today we're going to spend some time talking about the major extinctions that occurred here on Earth and what one extinction did to lead for another one's success. And so we're going to go through once again the different terms that we talked about previously with our geologic time scale. So if you have that, it might be handy to have it out, as well as go ahead and get out a sheet of paper and a pencil or pen as we kind of talk about some of these major events that have happened here on Earth. And so the first thing I kind of just want to go back and review is the idea of our geologic time scale. So remember that we have it broken down into eons and then our different eras. So Precambrian and the Phanerozoic are eons. And so these are huge time frames. Precambrian, remember, means not a lot of life is happening. Not a big explosion happened here in the Paleozoic. In the Hadean, the Archean, and the Proterozoic were very, very violent times on the Earth where lots of things that we see, continents, oceans, we're still kind of taking shape. In the Proterozoic, in our purple one right here, our Proterozoic, that's where it kind of started to calm down to allow for that life to kind of continue through. And so then we've spent most of our time talking about our eras, our Paleozoic, Mesozoic, and Cenozoic, and then the periods that fall within there. And that's where we're really familiarizing ourselves with. And so today we're going to talk and look at these periods and what leads one to jump into the next one, what's happening there to kind of cause us to be able to kind of break it down. And that has to do with a term that we've already used before, which is our index fossil. So geologic time is broken up by index fossils given an absolute time for the scale, meaning that it's allowing us to use relative dating, oldest at the bottom, youngest at the top, and then go back and radioactively date the elements that are present in that either rock around the fossil or sometimes even the fossil itself. And so once again, you can kind of see that progression of life here. We've talked about the Cambrian Ordovician. We have these nautilus and trilobites that are present, and then we clearly can get a little bit more developed as we move through. But these index fossils are the ones that are kind of helping us drive that whole process. So we once again use our relative dating to kind of help us figure that process out. So we've seen this picture before. We got a picture of the Grand Canyon here, and comparing rock layers based on location in the stratigraphy. Woo, that was one hard one to say today. Column gives you relative time, just meaning once again older layers on the bottom, younger layers are on the top. And so once again, most of the time with sedimentary rocks, they form in that nice flat horizontal pattern, but there are times that doesn't always work, and we get angular deformities, and we have cross-cutting, and we have intrusions, all these different things that can kind of cause way for scientists to be like, something had to be happening there that was causing the rock layers to become unstable, and let's go back and figure out what that was. So we're going to spend the time talking about these different eras. And eras are broken up by mass extinctions, meaning something died off, allowing another species to become more dominant. So natural selection, survival of the fittest. This is where kind of biology and earth science kind of interconnect just a little bit. So eras are broken up by mass extinctions. And mass extinctions can be caused by lots of things, and lots of things maybe are still unknown, but we are able to pinpoint it on either some type of meteor bombardment in the Earth's atmosphere or a large meteor making it all the way down to the Earth's crust. It can also have to do with climatic changes and or major events in plate tectonics, especially with a revving up of volcanic activity, which then can cause, normally volcanic activity that is really, really high is normally followed by some type of climatic change, and we'll kind of talk about that. So lots of mass extinctions. And so as you can see, 1, 2, 3, 4, 5 that we're going to kind of hit on and really go through a couple of different things. So the Ordovician is one. So once again, we kind of live in that Ordovician era about 10 million years ago. And what we're seeing is the ceased of the trilobite kind of moving through. Something happened to him, and he no longer continued on in his journey. His tree branch broke off somewhere. And then we also had another extinction during the Devonian, and that was due to some type of global cooling, loss of oxygen in the ocean, which caused just them all to become extinct again. We have then also the end of the Permian, which was probably one of the greater extinction. You can see the extinction rate at 95%. So this is a huge where a lot of life just went extinct. And so a lot of it has to do with, as you can see, the dramatic fluctuation in climate or sea levels. Something happened climatically to change the sea levels. An asteroid or a comet probably impacted. We can only speculate on that. This is an extremely long time ago. So more than likely that impact has probably been covered up or somehow recycled through the process of the rock cycle, and or several volcanic activities. But huge extinction here. As you can see, 85, 83, 95%, and then 50 and 40. So Permian, it was like major wipeout on the Earth. At the end of the Jurassic, this is where we have our dinosaurs going bye-bye. And so as you can see, the extinction rate was about at 80%. This caused a lot of different types of speculations, but we do believe it has to do with some types of volcanic eruption, a meteor hitting, and then climatic change, which could have been due to the meteor hitting that caused the Earth to cool off way too much for dinosaurs to be successful. And then finally, at the end of the Cretaceous era, we also see an extinction rate. There's once again our impact craters, several volcanic eruptions. So hopefully you're seeing a pattern here is that normally when volcanoes erupt a whole bunch, they also send gas and dust into our atmosphere, which can cause the sun to be blocked out, which is not a good thing. So there you go. There's another little show of our extinction rates. So late Ordovician, huge one. Devonian, small. Jurassic, pretty large. But when it's again that Ordovician one. Late Jurassic and the Tertiary one here with our Ice Age. So hazards that cause this, what I just kind of read through, is that as we see with every extinction, there is some type of environmental change. Either the Earth was getting too warmer, which makes it unstable for those creatures that have been living in an environment, so maybe their food sources were cut off, which then caused them to cut off, or it could be the opposite. Their ecosystem was too cold, and as they tried to migrate, they couldn't seem to find a place suitable for them to live. Growing up, I am a child of the 80s. One of the first movies I remember ever going to see was Littlefoot, which is about the bronchiosaur dinosaur, or the long necks. And so that movie, it's all about their environment, their ecosystem breaking down. You can see them go through these volcanic type sceneries where lots of dust and gas and this desolate type of environment as they seek the Great Valley where the tree leaves are, and that's where they want to be. So a huge environmental change. So we use the principle of uniformitarianism, the law of superposition, to kind of help us figure out what are some of these hazards. We look for that break where all of a sudden a fossil kind of just like ceased to exist anymore, and then we look at those other pieces of evidence, those VARB countings, those rate of deposition, to kind of figure out. Photosynthesis is probably like our biggest kind of helping figuring out these extinction rates, meaning that it's either really dominant or not. The ultimate demise of life on Earth as we know it was about 3.6 billion years ago, because we had these stromatolites kind of popping up everywhere, changing the environment, allowing oxygen to become more abundant, which allowed for life to take over. And so our first mass extinction was the Ordovician, which is one of our most earlier eras. And so we can see here the extinction due to regressive seas. So Pangea, or our continents, you can see kind of moved ever so much. And glaciers started to dominate, and it cooled off the earth, and it killed off our bryozoans and our brachiopods. These should look really familiar. We see these in our rocks here around in Kentucky. And so this extinction, this regression, meaning that the ocean levels dropped off, and because glaciers became more dominant, so they were sucking up the water to be in glaciers, which caused just the sea levels to change dramatically. The Devonian, too, was another huge mass extinction. We can see the change in how everything was fitting together with our plates. This Devonian extinction was affected only marine life, and usually benthic fauna, so just plants. And once again, something caused the water temperature in our oceans to change dramatically with either salinity levels, salt levels, or temperature, and it just caused a fluctuation within the life, which caused them to die off and become extinct.